All right. Well, possibility of a longer presentation today, so I'm going to go ahead and just get started. Today, we are going to be talking a lot about mobile applications and specifically Victron equipment and how it pairs so well with SimpliPhi batteries in mobile applications. We do have a co-host here today, Simon from Victron Energy. Simon, you want to go ahead and introduce yourself real quick so everybody believes me that you're here?
Even if you can't see me. Uh, yeah, no, my name is Simon. I'm one of the 4 sales managers for the North American market for Victron Energy here. So yeah, worked a little bit with Troy and Matt here in the past. We had another presentation about 3 or 4 months ago about mobile applications. So this will be a spin-off of that one with some more information and some new products for the mobile market as well. So yeah.
Awesome. Yeah, thanks for coming. Victron has a big line of products. There's always something new to discuss. So I'm really glad we're doing this again. And I imagine we'll continue.
I don't see why
So,
not.
yeah, without further ado, I'm going to give a brief overview of our company history and our products before we talk about Victron's products and then how our systems pair together. And we're also going to dive into some specific applications that we've seen with both of our products. So in 2010, we were actually founded as OES Energy, and we really were born in mobile solutions. So we were initially making lithium iron phosphate power packs for Hollywood filmmakers. Now, we were really founded to solve a problem, and that problem was unsafe lithium chemistries that were going into thermal runaway, and additionally the limitations of lead acid batteries in these mobile applications. Obviously, lead batteries are heavier and just have lower rates of charging and discharging. Just wasn't ideal for this application, of course. Now, in 2011 and 2012, we expanded into residential, military, and emergency response. Now, this was actually a huge stepping stone because military did not even want lithium batteries for their projects. The Department of Defense initially just said no, they're too dangerous and we don't want them. However, through rigorous testing, we were able to prove to them that our batteries were safe enough. They took them to Aberdeen Proving Grounds and gave our batteries a good test and decided to actually move forward with them on the project. So that was a big breakthrough. And then in 2013 and 14, we continued to expand our product line, really keeping in mind the customer and the installer. 2015 to 16, we relaunched as SimpliPhi Power. And in 2017, and still to this day, we are ramping up our manufacturing capacity at our location in Ventura County, California. So yes, all of our products are manufactured in California. All of our products are safe, meaning they're non-toxic and non-hazardous. This mainly comes from the lack of cobalt in our batteries, which also makes them so much more thermally stable. There's no risk of thermal runaway or fire propagation, and this has been tested and confirmed by the UL. We have special permission from the FAA to airship globally because of how safe and thermally stable our batteries are. And they've been deployed in more than 40 countries with well over 100 megawatt hours installed worldwide. Additionally, our solutions are versatile, integrating and optimizing with any generation source, on or off grid, wind, solar, generator, hydro. Really, the battery does not care what it's seeing as long as it's seeing the right DC power. So Victron solutions are going to help filter that DC power so it's the perfect voltage and current levels for our battery. In addition to solving the issue of unsafe lithium chemistries, we're also working to solve some larger, broader scale issues as well, like the limited access to safe, reliable, affordable, and sustainable power. Now, this issue entails escalating energy costs, especially here in the US. I'm sure Simon can speak to the European market, but this is really happening worldwide. Failing infrastructure. We've especially seen this here in California with the PSPS events, the Public Safety Power Shutoff events, and decarbonization, the growing demand for cities and utilities to have clean energy goals, but the lack of a clear path to meet them for some of those cities and utilities. Now, an overview of our products and our battery chemistry. We use lithium iron phosphate chemistry only, which has no danger of thermal runaway or fire, no toxic elements, and it's actually landfill safe. Now, the landfill safety, this is interesting as it actually does not have much to do with cobalt at all. It's really more around heavy metals like lead, for example. There's no abusive mining practices involved in the supply chain of our batteries. This is again due to the lack of cobalt, and no ventilation required, no cooling equipment required, and no safety monitoring equipment required. Additionally, it's able to withstand high temperature environments, up to 140 degrees Fahrenheit. As far as the specifications for our batteries, again, we've chosen lithium iron phosphate chemistry only. And when we look at form factor, pouch cells are often used in things like laptops and cell phones. Well, maybe not cell phones as much, but often in laptops and even smaller systems, smaller battery systems. However, these are more prone to puncture and swelling. Definitely not my recommendation for a mobile scenario. Prismatic cells are awesome as well, but they're just a bit bulkier, and when you're in a tight space, every inch counts. So we've chosen cylindrical cells to pack the biggest punch into the smallest package. I want to take 1 second here, and I totally forgot to do some housekeeping. Please type any Q&A questions, any questions you want Simon and myself to answer at the end of the presentation. Into the bottom of your screen, there's a Q&A bar. So go ahead and type those in there, and we'll get to all of them at the end if we don't answer them during the presentation. Now getting back to the content here, our Phi batteries are 3.8 kilowatt hours. They come in 24 volt or 48 volt options. Now, in mobile applications, I mainly see people using 24 volt as they often have some sort of DC load. If you do have DC loads, make sure you've got a Victron battery protect. We're going to talk a little bit about that device. That's going to prevent a battery from being drawn to a low voltage where it can be damaged. Our batteries are wired simply in parallel, and it's a simple wiring method, taking all the positive terminals to a common positive bus, and same with all the negative terminals. Using the same size, same length cable, this keeps them balanced so that they perform at their full capacity. Now our batteries are, recently we have changed the casing on the battery to be a white case. As you see, you're probably used to seeing the black case. So you'll probably see both floating around for a bit, but now this new white case is metal. So it's a bit sturdier. Unfortunately, it adds just a few pounds to the weight of the battery, but it's still only 84 pounds. So that's a light package and makes it easy for one person to carry it into a vehicle. And it's great because it's a small modular package. Additionally, our batteries come with an integrated BMS that's internal to the battery and adds protection as well as cell balancing, plus an integrated circuit breaker. Now, the circuit breaker I really love as it helps you install in small spaces. Additionally, we've got an even smaller package, the 12 volt, 1.4 kilowatt hour. It is also available in 24 volt if your system is 24 volt. And this is only 33 pounds and still scalable. You can parallel as many of these or the 3.8s as you want. Do not mix them. You can only use one or the other, but you can parallel any number of either battery. So I'm going to go ahead and hand this off to Simon from Victron to discuss Victron's products a little bit more.
All right. Thank you, Matt. Good start there. Before I get going, let me see if you guys can see me. I don't know if I'm able to do that, but and originally I was going to do this with my coworker Alan Santos Bush, but he was a little delayed as he was getting his second COVID shot, so he might jump in here towards the end if he gets back in time. So charging SimpliPhi batteries. We're going to talk specifically here about alternator charging, as that can sometimes preclude some circumstances that we need to make sure that we're working with, so that the alternator and the battery are well taken care of. So let's see if we can get this guy. There you go. So rule of thumb when you're charging a lithium battery off of a alternator is that if the alternator is smaller than the lithium battery, which is usually the scenario, then we need to use something to restrict the current from the alternator. When we're charging a SimpliPhi battery from an alternator, it's basically like staring down a black hole. That battery is going to take whatever it can from that alternator, and especially if we're idling, the RPM on an alternator will spin slower, so the fan in there doesn't have enough rotation to cool that alternator, and at that point we need to make sure that we're regulating the current going to the lithium battery. So the first thing that we need to look at is the size of the lithium battery compared to the alternator. So if it's smaller than the alternator, then we can use a standard battery combiner sort of system. But if it's bigger, then we should really put in something to restrict that current to keep that alternator protected. We have a couple of different options here. We have a DC to DC converter. It's a Smart Orion, and also a buck boost. Those are two slightly different units that comes in different sizes. So we're gonna take a look at that. And the first one is the buck boost. So this is a bigger unit. It's a 25, 50, or 100 amp, and it can be programmed to charge a 24 volt bank off of a 12 volt alternator, the other way around, or 12 to 12, 24 to 24. It's fully programmable for input set points, when to turn on, off, adjust current output, so on and so forth. It's got a single line output voltage, so we can set this to usually a couple of points above float voltage, and that's something we put as a non-isolated DC to DC charger in between the alternator and the house battery. Rule of thumb when considering putting in a DC to DC in between the starting battery and the lithium battery is that if we have a standard alternator, then we want to use about half of the capacity. So if we have 120 amp standard alternator, then we should really restrict it to around 60 amp or less at that point of time. The other option, a little bit more intuitive, but also a smaller unit, is the Orion TR Smart. So this is we have them in isolated and non-isolated versions, and connect the input to the starting battery, output to your lithium battery, and then we set a engine detection. So that means, well, we set the point of when the engine is running, so we're not discharging the starting battery when the alternator is not running. And then we can program the output to a 3-step charge. And all this is done on your cell phone through our Victron Connect app, where you can set your absorption voltage, float voltage, so on and so forth. Works really well with smart alternator, where it can have variable output voltages. It can also boost or buck the current. So if we have a 12 volt alternator, we can charge a 24-volt system, but you'd have to select the correct unit for that. So it's not like the buck boost where we can program it for whatever we have in 12 and 24-volt world. The difference between the isolated and non-isolated is that the non-isolated have a common ground versus the isolated have an isolated ground. Like in this picture here, you can see that we have two minuses, one for input and one for output. So we isolate the ground from the starting battery to the output here. Generally, in mobile applications, we still have a common ground in the system. So the non-isolated would be probably the one that we would go with, because the system is still not isolated. If we're using this for something more sensitive, radio equipment, more so on marine side, where we power a radio or an antenna, whatever it can be, where we don't want to carry over any noise from the common ground, then we can use the isolated to get a clean output DC without any noise from the rest of the system at that point in time. Yeah, you also have a little remote input here. So you can wire that in for a key ignition start if you'd wanted to. You can put a toggle switch on it. You can put a relay on it. A couple of other things that we'll get into. So this is what a system would look like with a isolated unit. We're taking input from the starting battery. Output goes to the house battery, and then we program it accordingly for the SimpliPhi battery here. Yeah, missed a little bit here. Should of course be the other way around, positive and negative there, but a fairly simple way to add some charging capabilities from your alternator. All these units, if programmed identically, can also be paralleled. So we can put 2, 3, 4, 5, quite a lot of them in parallel if we want to increase the charge current from the alternator to your lithium battery. So another thing with lithium batteries is that they don't like to be charged when it's cold. We want to try to keep that around, above freezing when we're charging it, or we could potentially ruin the batteries. And I know Matt could probably pipe in here in the end with some more specific about the SimpliPhi battery and how they handle cold temperature. But there's different ways to restrict different components based on temperature. So the first thing that we have, and this is fairly common, I would say, in different MPPTs, is that there's a low temperature cutoff. So we can set this based on the recommendations for the battery on when we want to stop charging. This is, however, based on the internal temperature of the MPPT here. So if this one is not in close proximity of the battery, well, then might be smart to consider using an external temperature sensor of some sort. Another way to do this is our battery monitor. We have a BMV712, which is a shunt-based battery monitor, and we can add a temp sensor to that battery monitor as well. So this way, a customer can see the temperature of the battery, and that gives you a good indication of where you're at if you're getting close to the low temp cutoff, so on and so forth. We also have a temp sensor that you can source separately that you wire into the shunt, and this allows you to read the temperature as well as state of charge, voltage, current, so on and so forth. And after that, on the back of the display, we have a relay, so we can control what we're doing when we're seeing a certain temperature. So when we connect this, it will pop a new option here. It says temperature controlled relay. And at that point, we can open and close a circuit based on the temperature that we're reading. So this can also be a way to control different devices when it's getting cold.
And Simon, just to clarify, that relay is on the back of the BMV 712. Is that right?
Correct. So this is the back of the display of a battery monitor. So like Matt was saying, the battery protect, this is one way that we can turn DC loads on and off. So if we connect for example, a SimpliPhi battery up and then are in and out is passing through this battery protect. The battery protect is a basically a solid state switch, and we can program this to terminate the load here based on voltage or other things, relay inputs. So in this case, we could just wire the normally closed and common into your remote pin on this one here. And at that point, this relay here is basically like a toggle switch on off, but instead of switching that toggle switch with our thumb, we're telling it to open and close based on temperature. So now we can turn off DC loads here, or it could be a charge if we have this one the other way. And at that point, we can control our loads and chargers based on temperature. So this can be pretty handy. We can use it the other way around as well. While it's getting cold, DC load connected on the output here, turn on a heating pad, for example, to keep the battery warm so that we're not getting into a low temp shutdown, and then we'll set our parameters for on and off and when we want to drive that load as well. So you can see here, here's just a little schematic on how a relay works. It's pretty straightforward. If we have a normally closed circuit, well, the contact in between here is closed. And when we energize the little coil here, then it opens. And if we go into the normally open, well, it's the other way around. And this is just a way to send that signal out based on what we're seeing. There's a lot of other things that we can control, and basically anything that's got a remote input, relay can only carry about 1 amp. So if we have a remote port on various devices, MPPTs, inverters, inverter chargers, quite a lot of different things, then we can wire this directly in here and turn it on and off based on temperature as well. Usually we have the low voltage cutoff built into a inverter or an inverter charger, but the temperature can sometimes be different depending on chemistries and so on. So it's good practice to take a look at this at that point in time. So you can use this for controlling your loads even further. And if we don't have something, then we could potentially use a battery protect or any type of solid state switching with an input. This battery protect will not work with an inverter because there's capacitors in here, but with all your DC loads or DC charge sources. It's just good to know that it's not bidirectional. So if you have charges and loads that you need to control, then you need 2 of these. A little bit more technical, if you have an inverter charger like our MultiPlus, then you can also use the same relay and from the battery monitor to shut off your charger based on low temperature. So there's an assistant or a program inside of our inverter charger where you can turn the charger or disable the charger when it gets this signal from the battery monitor. So we can also control this through an inverter charger. That's a little bit more sophisticated. All right. Another thing with Victron that a lot of customers are using is the monitoring aspect of our products. And we just launched a new product. It's called the Global Link 520. And this is a simple product, very easy to use. And it works on cell, LTE-M, which is the Internet of Things. So this unit here is used to remotely monitor, and you can even control the relay from anywhere in the world, even without an internet connection. So it simply connects up with power and a couple of your products, and now you can see them on the cloud instantaneously. There's a 5-year prepaid cell plan inside of this unit. So as soon as you connect it to power, you'll start sending out information up to our VRM cloud, which is a free program to use. And you can keep your units up to date. You can trigger the relay if you want to. Well, it's similar like the battery monitor. You want to start a light outside of something, you connect that relay to a battery protect, and then you turn that battery protect on and off. Or you can have it for starting a generator or quite a couple of different ways to use this here. So yeah, it works right out of the box, connected up to power, and it'll start sending data. Here's a couple of things that we can see with this unit. For example, if you have a battery monitor, then you can see state of charge, battery current, voltage, MPPT, you can see solar production, so on and so forth. If there's an error code, then it will also send that out as well. You can add an external antenna to this. So if you are traveling far out where there's no really strong cell signal, you can add this and have that placed outside of a van or a RV or something similar. This LTE connection works on AT&T and T-Mobile here in the US, so that should cover most of, well, all of the US, I would say almost, depending on where you're at. So you got pretty good coverage for this one. Same with Canada, you have some of the biggest operators supporting this as well. Since this is based on a cell signal, we have that 5-year data plan inside of it, and to save the data plan from running out in a couple of years, all information is sent out every 15 minutes. There you go. So this is what a system would look like if you have a SimpliPhi lithium battery, for example, and you want to know state of charge, so on, remotely without much hassle. You can install a battery monitor and just connect this global link up to the system, and then there's a little cable that goes in between the global link and the battery monitor, and this is really all you need. And this way you can keep a track of your system from anywhere in the world. The next thing that we have coming for the mobile market, and this is already out here in the US, we've had our first batch coming out, is our new MultiPlus-II inverter charger. And this is a 12240 volt unit, very similar to our traditional MultiPlus, but instead it's a new form factor, and it's got L1, L2 neutral ground on input and on output as well. So this makes it easier for installations when you have a 50 amp service on your vehicle. Form factor a bit different, a little skinnier, a little taller than the old one, and also the connection points looks a little bit different. We've increased the AC side of things, so now it's 4 gauge instead of 6 gauge where we have on the standard multi. There is a relay down on the bottom now instead, and yeah, the general type of relays that we have and protocols that we can connect this up to our touch screens or so on and so forth is right there. A little on-off switch down here instead of on the middle of the unit. So the way it works is if we have a 50 amp service connected to our RV or our boat, at that point we have this connecting to the relay, the transfer relay, and at this point we connect the input from the shore power directly to our AC load center, and at that point we'll have 12240 on the output with a phase angle of 180 degrees, and that's how we get our 240 volt loads to power up as well. It could be less in these situations where we're connecting to a 3-phase. At that point it would be 120 volt phase angle, but most of the RV parks and so on is 50 amp split phase 12240. We can pass through 50 amps on each leg, so that's L1 and L2. So we can take quite a lot of power from the shore power here if we need a lot of, if we have high consumers on our inside of our RV. We can only power assist on L1. So this is good to know when you're installing this unit. Power assist is when we supplement the shore power from and the battery to make more energy, basically. So if we have limited AC input, then we can add the inverter to that. Would we need more for a larger load? So the inverter can go up to its capacity to supplement the grid at that point of time. It can be handy if you're trying to start up an air conditioner and you're at someone's house and you only have a 15 amp or a 20 amp, whatever it may be, a shore power connection, single phase. Well, then we can supplement that so you can start it up, and then after that load starts to settle, it'll divert back to a charging state. We can have a single phase input. So this is just generally our 30 amp AC input. So at that point, we will connect both L1 and L2 on the output. So even though we just have one leg coming in to the system, we will power up L1 and L2. So both sides of your breaker will be powered up with 120 volt. The difference here is that now we have 0 volts in between the two lines. So you have 120 volt on each side of the breakers, but we don't have the ability to run our true 240 volt loads. That would be washing machine or something similar that needs that 240 volt load. But all your 120 volt loads on either side of the breaker will be powered from that single input here. And if we don't have any input, we'll use it as an inverter. Well, then we'll have the same setup here. We have 120 volt on each side of the breaker, but we don't have that 240 volt or the 180 degree phase angle to it. So we can power all our 120 volt loads from inverter on both sides of the breaker. To make this a little bit more interesting, we also have a relay on the AC output too. So this is something that we can program. So you can potentially have 4 different outputs, quite a lot here. Some of that are only active when we're connected to shore power, some that are active when we're connected to inverter, so on, so forth. You can control that relay for this here if you want to install a dump load, whatever you want to do. So it's all in all, it's a straightforward installation. If we have a 50 amp 12240 input, well, we can connect it directly into the unit, and then it goes out and then into your AC breaker panel, and we can power both sides of the breakers here at all time. And when we have shore power connected to it in a split phase configuration, we'll have a 240 volt load in between the two breakers here as well. Yeah, a little slimmer, and we can also parallel these units if we need more power than 3 kVA, and then we can put 6 of them in parallel, so that's per phase. And we can add another stack to give you a true 240 while inverting, or we can do 3 phase, and you can put 6 per phase, so you can make quite big systems here. I think that's most of this here. I think we'll have some questions coming to us after this here. Do you have anything to add, Matt?
No, I guess I do want to just highlight the incredible advantage to charging, preventing charging below freezing. I think I want to just highlight that because that is something, probably the main question we get as far as mobile systems is how do we keep this from charging below freezing? Because people like myself with a camper van, we're not always staying in sunny California. I like to take trips to Arizona or Nevada, and in the winter it gets really cold there, and the morning sun can end up charging your batteries below freezing. So I think that's just something that I want to point out as an awesome advantage of Victron's products, and how easy it is to program is just through your cell phone. So that's something I really like.
Yeah, and we'll have our email here in the end as well if you have any specific questions about this. There's quite a lot of different options. So yeah, if you have a system and you think about something after this webinar, just shoot us an email and we'll take a look at it.
Yeah, agreed. We are also happy to assist with system design. So to jump into some advantages of combining both of our products, Phi as well as Victron, in one system. One point is the high energy density. So as far as I've seen, we have the highest energy density on the market, 7% more energy dense than one of our most common competitors in the mobile space. It's really going to help you maximize your energy in a small space. Now, I actually ended up having to build a custom lithium battery to fit in a very tiny space inside of my camper van. It was also a fun project for me, but I think these space concerns are very real for a lot of us, especially if you have maybe a lead acid battery or a different lithium battery that you're replacing, and you don't want to build a new enclosure for it. That was kind of my situation, as I had a big old cabinet inside of my camper. I didn't want to replace the whole cabinet, just the battery. So it really helps to have this high energy density. And in addition to that, the high power availability. Now, I know in a lot of these mobile systems, you don't have a whole lot of consistent load. You might have a 10-watt overnight load from an inverter, but often you're just using your energy for maybe 10 to 20 minutes to microwave some food at night. So it's really nice to have this C/2 max charging current as well. Now, that's also the C/2 max charging current and discharging current is not only going to help you utilize your energy for large loads that are temporary, but it's also going to help you maximize PV production and cut down on the time you're going to need to stop to plug into the grid, as well as minimize the time you're going to be idling your engine to, charge through your alternator. So, in addition to that, I, of course, like to highlight the breaker on the top of our batteries. This is going to make an easier installation, especially in these tight spaces. Can't tell you how many times I've been doing yoga positions to get these batteries installed. After the fact, I really suggest you install them first. Do your electrical first before you put in all your insulation and whatnot. Now, another advantage of Phi batteries is that there's no maintenance and no toxic ventilation. No toxicity within the battery and no ventilation requirements. Another big advantage for mobile systems. There's no significant loss in temperature or significant loss in capacity as the temperature decreases. This is something we see a lot in lead acid batteries. Additionally, the longer cycle life offered by lithium batteries compared to lead acid batteries is another important factor here. We've got a 10-year warranty life with 80% end of life capacity remaining at the end of those 10 years. This is going to allow you to spend less time in those tight spaces installing and maintaining your system. Now, I'm not going to run through these right now, but we have an awesome calculator on our website for levelized cost of energy storage. This is going to tell you the cost per kilowatt hour of your battery. You can compare Phi batteries to any other batteries on the market, any chemistry, and any depth of discharge. And what this is going to do is help you understand the return on investment of your battery more than just seeing, the upfront cost, which is honestly not the most important factor. Additionally, we've got our lead acid replacement calculator. This is basically just going to take into account the size of your lead acid battery bank and allow you to size a lithium replacement. So we've got over a decade of experience, again, in the mobile industry. Myself and Troy have definitely done plenty of mobile installs. I actually worked at a camper van conversion company before this, and it was a ton of fun, and definitely got a chance to use plenty of Victron's products hands-on. As I mentioned, our roots are in mobile applications, and Another advantage of our batteries that I wanted to bring up here is the flexible sizing. So you can not only parallel an infinite number of our batteries, and you have a small building block to work with, but you can actually go back later and add more capacity if your needs grow. So if you do decide to, add a microwave to your van and you didn't have one before, that's something you can actually go back later and add a battery for. Whereas most manufacturers are gonna want you to have all the batteries in up front. Additionally, our batteries are really nice for DIY projects for several reasons. Now, one is because they are compatible with so many different types of, charge controllers and inverters. Victron obviously being the top choice, and the ease of programming of both components. So SimpliPhi has made it very accessible to find our set points on our website. And if you can't find them, our tech support team is here to assist you, whether you're a DIY installer or a seasoned veteran installer. And those set points are easy to program in via Bluetooth to your smart Victron devices.
And that's something that I just wanted to add to, Matt. We have something called a demo library. So if you're not familiar with our products, or the screens that we showed on some of the programming look new to you, it would be good to download Victron Connect from your app store, and then you can select the demo mode. And there you can play around with all our Bluetooth integrated products and see what they will look like in a real world, and what set points you have and what kind of options you have with it. So that's a good way to get used to a product, especially ahead of considering a purchase of one.
Yeah, that's another big advantage. And in addition, a tech support team that picks up the phone from your side as well, which is really helpful.
Yeah.
We've also got a distribution network that allows for our prices to stay low and our availability to be um, struggling for a word here. Our batteries are widely and quickly available due to our distribution network. And this is helpful because a lot of these camper vans are on rough timelines.
Yeah.
So here is an example of a system we've seen. It's obviously quite simple. Um, I like how they've done all the wiring here on a wooden board. We often saw this when I was working at the camper van conversion company. But what I wanted to point out here is actually my own system is what I wanted to talk about a bit. Is I have, I spoke about the battery that I built to fit into a certain space. I've actually got a current limiting combiner between my starter battery and my lithium battery. Now, does it work? Sure, it works. It will charge my battery somewhat, but it is what we call the good enough system. It's not perfect. It's not going to get my battery through an absorbed charging stage, and it's just basically partially functional. So the current limiting combiner definitely is not as strong as the what I'm looking at now. Upgrading to is the non-isolated Orion. Probably, I guess, just the 30 amp is really all I need. 12 volt to 12 volt converter. So that's because my grounds are combined, is why I would want the non-isolated there.
Yeah, and then just to add, when you're working with a alternator and you're charging a secondary battery like a lithium battery, a lot of new alternators, especially newer vehicle, have a smart alternator where the output voltage can vary. So you can go up to 14.4 if it's 12 volt. And then when it's up and running, you can very well go down to 13.2 or similar. So using a standard, charge relay could, at that point, which have set points for when he wants to connect and disconnect the alternator, it can turn on and off just because the output of the alternator fluctuates, making it very difficult to work with, and it'll do funny things. So having something where you can program that input tolerances according to your alternator, it can really make for a smoother system, and you can get a 3-step full charge off of your alternator, even if the alternator is quote unquote idling at lower voltage, because all the demands are filled on the starting side.
Yeah, absolutely. And I wouldn't recommend anybody use the type of combiner that I have. In most cases, it was something I installed actually for an AGM battery, and haven't gotten around to taking it out yet. And I've only had this new battery in there for a little while. So, um, you know, adding the correct equipment like a Victron MPPT charge controller, where you can hit the exact set points of the battery with that, or the Orion, smart charger. This is going to help you avoid a system that's just partially functional and maybe limited in charging capabilities, and really help you hit the exact set points that are needed to optimize our battery's lifespan and performance as far as capacity.
Yeah. So
Luckily,
I would say all of our products here, they're fairly customized, so we can get the set points. If we need to limit the current from a big inverter charger, for example, then we can do that through programming as well. I saw that my coworker Alan just came in here. Perfect timing, Alan. So I don't know if you have something to pipe in here with, or say
Hello.
hi, or
Yeah,
introduce yourself.
Hi, everyone. Yeah, I just joined, but I was answering some of the questions in Q&A.
Oh,
so I'll
perfect.
stay on that if you'd like. I'll stay here listening. And
Okay.
if there's any questions, yeah, just please chime in. Thanks.
Perfect.
sure. Yeah, another advantage is that lead acid batteries are easily damaged by remaining in a partial state of charge. And I do see this a lot in camper vans. Let's say you parked in partial sun and you're just not quite, getting to absorb an EQ charge in too often. When you change over to lithium batteries, they are not damaged by remaining in a partial state of charge. So this is another advantage of switching over to Phi batteries and Victron chargers. Now I want to just display a few use cases. For example, we have seen our batteries in a tiny home on wheels. Now our batteries have been UL tested as well as UN certified for flight. So that means they've been through rigorous vibration, shock, drop testing, all sorts of testing to ensure that they're not going to cause any catastrophes or even fail during vibration, and just generally the type of motion you would see from sailboats, RVs, tiny homes, things along those lines. We've seen this awesome trailer with these cool butterfly style solar panels from an awesome customer of ours named Doug. And I do like the covers he's thrown on here, as a lot of people, as we showed the wood earlier, that's an option to have your wires exposed, but of course these covers do make it pretty beautiful. And of course, like my own camper van, which I'll soon throw the Orion charger into. We're getting additionally more and more inquiries nowadays from mobile businesses like food trucks. And I see that these need a larger capacity often, so the 3.8 is usually a better bet for these than the 1.4. 1.4 might be a better bet for some of you camper van weekenders, for example. Or if you need a 12-volt system, the 1.4 is the way to go.
Yeah, and this is a growing market here as well. If you're a distributor or a dealer, these mobile coffee vans, food trucks, so on and so forth, they're used to running a generator all the time. And yeah, depending on where you're going, there could be regulations on if you can run a generator or not. But using a system with SimpliPhi battery to store that excess power, generally we're not running that alternator at ultimate capacity when it's running. It's just there to power the loads, regardless of what it is. And all that excess can be used through an inverter charger to fill up a battery, and then you can turn it off and then just use your battery for the remaining time, and then when you need it, you just start that generator up again. And that way you can put in a fairly compact and small system to sort of bridge the generator time and usage there as well. So that's something that's growing in demand here, sort of a hybrid solution where it's more a compact, smaller system and use the generator more as a backup as compared to the primary power source.
Definitely growing in demand, and I think that's a kind of a highlight to any installers listening, that if you're looking to expand into a new market or get more business, this is something you could look into. And so I want to say thank you to everybody for joining. Hope you enjoyed it, and we're going to go ahead and jump into the Q&A now. And one thing I wanted to point out is to Simon and Alan, if you guys want to touch on the Lynx power distribution system, I think that's what I see most often used as a bus bar uh, in these mobile systems. I think it's a great option. So if you guys had any like main points you wanted to
Yeah, can you maybe bring one up on the screen if you maybe take a minute there? Before also, this is the email down here, Sales USA Canada, Victron Energy and training at simpliphipower.com for if you need questions or if you're looking for a distributor in your area to talk to further about a system, or if you need help from us. Those are good emails here. The Sales USA Canada is a joint mailbox that me, Alan, and our other two colleagues, Rich and Justin, are monitoring every day. So, yeah.
Hang on just a second here. I'm pulling up a Lynx distribution system.
There is a question in the Q&A I don't have an answer for, Troy, and
oh yeah, 1 second.
Thank you.
Okay. Yeah, so this is the distribution modules that we offer. The most popular one is the Lynx Distributor. And let's see if you can move on maybe to the next slide here. Is that a possibility where we can see the open cover? There you go. Go to the next one, where is the Lynx Distributor. There you go. So this is a 1000 amp bus bar, positive and negative, and it's got 4 slots where you can put in your fuses, so you can individually fuse your components and your consumers, such as an inverter charger, MPPT, DC to DC, whatever it may be, and you'll have them join at the output of this distribution block to connect to your batteries. So it's a very simple way of combining everything and keeping it nice and tucked away. There's no exposed fuses. There's no exposed contact points except for the ones that are sticking out on the top there. And yeah, it makes for a really clean and nice and neat installation for your whole system, and then makes it easier for a end user. If you're an installer, if something happens, then you can label these fuses. You can put MPPT, inverter charger, so on and so forth, and then you can check on the fuse and make sure that's usually the first place you check and see if something is going wrong. So there's also a circuit board on the back here. So if we apply 5 volts to this circuit board, where we have what's called an RJ11 little contactor on the top of the board there, the LEDs will light up and it'll indicate green or red, so you can actually see if a fuse have blown without even taking the cover off. This is also if you use one of our Lynx shunt, for example, which is a battery monitor, then that one will have one of those cables to connect directly to it here, or you can use any sort of step downs from 12 or 24 volt, whatever your system may be, down to 5 volt, and power this up as well. So that way you can see your fuse health just by looking at the unit as well. So it's a good compact unit to combine all your fusing on, and you can also link more of them together, like we saw in the first picture. So there's slots for you to, you see on the bottom right here, you have 2 connection points, and where you can connect another Lynx distributor, and at that point you can make even bigger systems where you need more fuse holders.
Yeah, I really like how this is expandable Now, as I mentioned, our batteries, you can go back later and add additional batteries. And so that's a nice thing here is you don't have to just go out and buy a new larger bus bar and rewire everything. You can just add an additional distributor or power in.
Yeah.
So hi there, I missed the presentation again and the one a few months back. Yeah, those are both going to be available on YouTube shortly. The old mobile presentation is already on YouTube, and this one will be there shortly. We'll actually email every registrant a link to that when it's ready, probably tomorrow. Got a great question here. If I'm supposed to carry an 84-pound battery myself, does that mean I can cancel my current gym membership, or that I need to get a new one? I'd say after after you're lugging that 84-pound battery, you probably ready to drop your Planet Fitness membership, maybe upgrade to Gold's Gym after that. So that's a great question. Does the SimpliPhi battery have a built-in low temperature BMS charging cutoff? So the Phi battery does not have a built-in low temperature charging cutoff. The SimpliPhi battery does have that protection when it's paired with a communicating inverter. Right now, it's really just designed to work with the SolarArc inverter, and the SolarArc I have not seen used in mobile applications. I would imagine it's not ideal for mobile applications, so we can dive into that later if needed.
Yeah, and if you need more information on that, just shoot us an email or go through the presentation again. There's several different ways, and I didn't include all the different ways that we can.
Yeah. Can I add something about the SolarArc?
Yeah, please do.
I know for sure they don't have a neutral to ground relay switching, so that right there would imply not
a grid tied option.
Tie only. That's what I understand. I don't know if they have in development a mobile version, but yeah, it wouldn't make sense to me.
Yeah. Can you expand on the 3-phase option? Yeah, so all our inverter charger can be stacked and parallel, so we can put 6 units of all our inverter charger, whether it's a single phase 120 volt, if it's the 120/240 option, or yeah, all of them, and then we can put 3 of them together and then create that 120-degree angle for 3-phase output, and then we can put 6 per phase for a really large system. So that's the way that we can work with 120 or a 120/240 volt load, or a 3-phase load as well. So you would need 3 units for a 3-phase load, and just use one of our configure tools and program them to the phase rotation, so you have that. Hopefully that answers the question. Do you want to add something, Alan, to that?
Yeah, the 3-phase, well, yeah, there are diagrams. Someone asked about schematics, and we are adding schematics to our website downloads section. So you can take a look there for different applications, including 3-phase. And the search field works great. So, if you put in 3-phase, 3-phase or parallel operation in the search field of our website, you'll get a plethora of white papers there.
And there's also a training specifically on 3-phase, how to wire it in, how to program it, and all these kind of ins and out of a 3-phase system in our Victron Professional training section. So Victron Professional is the backside of our website, where you can create a end user, dealer, installer login, and we have probably 20 plus training seminars there. So one of them is specifically for 3-phase, and where it goes through how to wire it in and how to program it. And after that, you get questions and you can print out a certificate if you pass it, so on. But that training specifically there, it comes with a 30-minute video, I would say, where it goes into detail about all these and makes it very intuitive, I would say as well. So that would be a great start if you're looking for a 3-phase system.
Yeah, thanks for those details. So we got what looks like to be a tech support inquiry here. It sounds like somebody has a blue smart IP22 24 volt, 16 amp charger, and it's reverting to 1 hour absorb time. Um,
This
if
is
you're unable
yeah.
to, if you're unable to reach that 6-minute absorb time for whatever reason, you can always decrease the absorb voltage to 27.2, or for a 48 volt battery, that'd be double that, 54.4.
Yeah, and as of right now, our um, lowest timer on the absorption is 1 hour. Now this is a max time, so it's not a set time all the time. It could be less than that hour, but the max time before we force the unit into float at that point is 1 hour. So generally, it will probably be a little bit less because there's also the aspect of seeing how much current goes into the battery, how much it can accept at that voltage. So when we reach a certain threshold where we consider this battery full, it will go to float. So it could be way less than that, but yeah, max 1 hour. And I've seen this inquiry from other people as well about being able to lower this way lower. So generally, when we see a lot of inquiries about something like this, then eventually we'll have an update to our firmware where it fixes it. So thank you for that.
Yeah, that's the adaptive absorb time. I've seen that. Okay, so the Phi 3.8 has a built-in breaker. Just wondering if there is one on the 1.4. There is not a built-in breaker on the 1.4. There is a built-in BMS, but additionally, if you use this Lynx Distributor, you can add a fuse. So that would be, sufficient for your overcurrent protection if you had the 1.4. All right. I'm concerned about installing the batteries in a mobile application where it's going to see extended vibration from being highly used. So that's a great question. There is no anticipated degradation of the battery. I don't see any reliability concern, and the energy density is not going to decrease in that scenario. So we've been through extensive U and DOT testing as well as UL listings, all the testing required for those, and the vibration and as well as impact like shock are all a part of those tests. Really have not seen any issues with our batteries in those, and they've been used in mobile applications countless times. So I really don't see an issue there.
Would you say that the main difference here for vibration is the parallel connections in between the cells and how you weld those cells together and what kind of material you use on those? Is that a big part of vibration issues? Or
Yeah, definitely. And seeing does the interior of the battery allow for a slight bit of flex, actually? Because if it's too rigid, that's also going to cause issues. And that's the reason that you don't want to use a rigid bus bar across the top of the batteries when wiring them. You don't want the bus bar directly on the terminals because it's rigid. You want to use the cabling to this distributor because it has some flex in there. So it's the same concept in the interior of the battery, right? It needs to be secured and cushioned to an extent, but allowed to flex as well.
okay.
Awesome. So let's see. I'm going to hop into the answered questions because we are running out of time here, but I want to see if any of these already answered questions would be good for everybody to hear. So detailed system designs can be found on Victron's website in the download section. They have a number of schematics there, and also, we're always happy to point you toward those if you can't find them.
Yeah. I see one here. It looks like there's two questions, same from Taylor, about alternator charging and solar and offshore charging. So the MultiPlus is just an inverter charger in that aspect. So it will convert AC to DC. So it's a charger. So it doesn't have any interaction per se with what we're seeing coming in from the alternator. Same with the solar input. what we have is a Servo GX, which is a communication device. So we can have the inverter charger communicate with this Servo or color control. And we can also have the solar MPPT, for example, communicate with that. And at that point, we can take the combined charging sources into account. Would we need to set a max total charge current going into the battery? And we can also add a battery monitor so we can actually see how much is coming in. And that way we can have them sort of work a little bit more in conjunction with each other. But it's not something that's inside of the MultiPlus. The MultiPlus is just taking AC input to charge and to power your AC loads.
Another good one here. Have you tested your batteries under a constant load scenario? Meaning I have a constant 24-volt load and keep a Victron charger on the battery at all times until I lose shore power. What is the cycle life of your batteries in this application? So yeah, that's not going to degrade the battery. What's going to be happening there is basically the power is going to be bypassing the battery. The battery is going to stay full and stay floating or at a storage voltage that you've specified until you lose shore power. And that's not even what I would consider a cycle, right? So a cycle would be you draining the battery and then recharging it. So you can expect approximately 10,000 cycles out of our batteries, and the constant load scenario wouldn't even really degrade the battery.
Yeah, one thing to add to that, just to touch on it, if you have a constant load, you may use this unit as a power supply, and that point, just beware if you lose power and you discharge it, that you need to change the settings on it to a charger if you put a cycle on the battery because of a power loss. If you have loads that does not need to be 24 volt specifically, then you may also be able to just keep the charger and keep the battery in float all the time. So that would probably be the best one, but I guess it would depend on the sensitivity of your load at that point in time.
Yeah. Awesome. Well, that is all I see, and I am ready to wrap up. Anything you guys want to add last minute?
Do you have anything, Alan?
I don't. I'm sorry I missed most of this. I got my COVID shot today.
Yeah. So hopefully that's an indication that we can turn some of these presentations into something live one day here, hopefully. So
hands-on someday.
yeah, hands-on.
Yeah.
That'd be nice.
Absolutely. I'm actually
thank you for
recovering from
joining.
my shot right now.
There you go. And I had mine today too, so it seems like
Coincidence.
that kind of a day. Excellent.
Well, appreciate you guys joining for this, and looking forward to doing it again sometime. Thank you, everybody, for joining.
Yeah. Take care. Thanks for having us.
I did see one here before you click out, Matt, that just came in. Does the battery protect connect to the charger and or battery monitor? So the battery protect is a low voltage switch, but we can control it externally with a relay. So just think of it as we are putting a light bulb on the output of the battery protect and a battery on the input. And then when we switch the switch or the remote input, then we turn the light bulb on and off. So we can do this. We can also control that with the battery monitor. If you have a charger, it needs to have a relay port to be able to control it, but we can also base voltages here for on and off. So the battery protect is just something that can protect your batteries from draining, or it can be used for a charger to sort of protect your battery if you need to set a a certain voltage, if it's or if it needs a relay from a BMS or so on. So yeah, it could be handy either or, but it's good to know that it is not bidirectional, so it would have to either be used for a charger or for a load.
Yeah, and Alan and I both just hinted at something hands-on for next training. So we'll either have to tour my van or your guys' mobile situation.
We are going to have a big toy hauler actually being built for us. So we'll have a live room with 6 application examples, and yeah, so it'll be a really nice thing to have go around to our distributors and customers.
Perfect.
Here.
All right, guys.
For
Thanks again.
for
I'll see you
contact,
next time.
email contact, I think, SimpliPhi, you have an info email.
I sent ours as well directly in the chat box there. Okay.
All right. Have a great day.
Thank you.